Good afternoon, everybody, and welcome to this session today. Before we get started, I just wanted to do a quick survey of the room. Who in this room today is currently building or deploying using containers? Okay, a fair few. 80% of all containers that run in the cloud today run in AWS. And according to the CNCF, nearly half of all organizations today are developing and using containers for their IT systems, which kind of matches the number of hands that we saw up in the room just then. But there's no single way to do this. There's no single way to architect a really good container solution. My name is Natasha Wright. I'm a container specialist here at AWS, and I work with customers every day that are trying to navigate that journey to architect their container solutions.
And this journey has a lot of technical design considerations. My name is Robert Northard. I'm a container specialist at AWS, and I help customers build well-architected container solutions every day. And today, we're going to talk about the different capabilities that compose a well-architected container solution and how you might get started with building containers on AWS today. Thank you, Tash.
Container adoption is rapidly growing, so let's take a second just to explore why. IT system change is constant. Whether you are modernizing an old workload, whether you're building new features, enhancing existing features, fixing features that don't work, whether you're making IT changes to close and implement security fixes and hardening to your systems, or whether you're looking to innovate, IT system change is constant, and containers are one way to help you accelerate and embrace that IT system change. Our customers that are on that IT change journey tell us they really want their teams to spend time developing applications. They don't want their teams to spend time on infrastructure. They want to use managed infrastructure, and they want that managed infrastructure to be scalable, to be reliable, to be durable, to be customized and configured in a way that meets their scaling needs, but most of all is secure at all levels. And that brings us to containers. And really it's that change that's driving customers to containers. And if we think for a second then about what container technology really is, what we're thinking about and holding in our minds is a standardized way of creating almost an executable bundle or package of your application and everything that it needs to run, all of its dependencies, all of its configuration. And because you've got this standard, that means there's operational gains there to be had, because you've got one approach to stopping and starting, maybe a defined approach for logging. And it's not just operational gains that you can have with containers. There is also a standardized, repeatable, and automatable approach to deployment. And then that means you can speed up your time to market because you can release more features quickly. But something I want to pause for a second on is this idea of flexibility and portability through containers. Containers are lightweight. You can ship them around really easily to lots of different locations, and that makes them highly portable. And because we have this standard that's wrapped around the containers that we're building, we have a standardized way that we want to interact with them. And that's given rise to a number of different extensions and ways that you can interact with and extend the capabilities of your container. And this makes your solutions not only super flexible and portable, but it really maximizes the ways for you to deploy to the different systems that you have. You can really maximize the how and the where of your container systems. And customers that are using containers with AWS are building a variety of things. They're building DevOps platforms and CI/CD tools. They're building machine learning applications. But what those customers say to us is, how do we now move from understanding and really knowing the value of containers to being able to build and architect and deploy a really good container solution. And if you're building a container solution, as I feel like many of you in the room are from your hands up, you're going to have a lot of capabilities that you need to consider. So let's try and build out some of those capabilities now and figure out what they might be. So let's imagine you have your containerized workload, and this could be anything. It could be Node.js, could be Java, could be your new machine learning application, but you have your containerized workload. Next, you're going to need a way to organize, store, and deploy the container images associated with that workload. So you're probably going to need some sort of registry capability that allows you to store, tag, and label a container image. You're then going to need DevOps tools or a pipeline to deploy that container image. You're then going to need some compute to actually run that container itself. So your virtual compute, your storage, your networking, these are the component parts that are going to help you run that container. And if you've got not one container, but hundreds of containers, or perhaps thousands of containers, you may also need a container orchestrator to help you manage scheduling the large number of containers at scale. So once you've got your container image deployed, you're going to need to interrogate that container, see how it's running, is it working? You're going to need an observability capability that provides you with logging, monitoring, telemetry data, and also alerting when things go wrong. You're then going to need to understand and interrogate the security posture of your container and also all of the interactions that it makes, all of those systems that it needs to connect to, and all of those systems that need to connect to it. So you're going to need some sort of security and then RBAC capability as well. And finally, day two, you're also going to need to think about and understand how to do things like patching and upgrades, backup and disaster recovery, capacity management. Now, don't think of these capabilities as an exhaustive list of everything that your system must have. And if you don't have these, your system is in some way wrong or bad. But think of these as a way to drive a set of requirements or principles of how you can create a really well-architected container solution. It could well be that some of these capabilities aren't necessarily applicable for your organization or for your needs, or maybe you need far more than what we've got on this slide here. Once you've mapped out what your solution looks like and all of the capabilities you need, you then need to deploy it somewhere. And ideally, you want to deploy that solution as close to your customers as you can. But what do you do then when you've got a solution that you've deployed really close to your customers, and then there's a new market that opens up that you want to expand into, or a new regulatory compliance or rule that you need to comply with, and you now need to consider a different deployment location for your container solution? With AWS, and specifically running containers with AWS, you do have a broad set of options. You can run your containers in region using our AWS in region cloud. You can run your containers at the edge using local zones and wavelength locations. And you can also run your containers on premises with AWS Outposts, and even running containers on customer managed infrastructure through our ECS Anywhere and EKS Anywhere services. But our customers that are deploying container solutions to various deployment locations tell us that the one thing that they really care about is consistency. And that's consistency for their platform operators, for their engineers, for their developers, for their other operational and support function teams. They want these teams to be able to interact with their container platform either in exactly the same way, or when they interact with their container platform, they want to achieve exactly the same outcome with their interactions. And this, to be honest with you, is really a balancing act. As you think about the number of locations where you need to deploy your system, you're going to need to make a decision about how you want to architect that container solution. Do you want to architect a solution that's like for like in every single deployment location? If this is what you're striving towards, you're probably not going to be looking at managed services, and instead you might be looking at open source, third-party tools or cloud-native tools, so that you can pick the best tool for a given capability and ensure that tool or that service or that technology exists in each of your deployment locations. Now, this is great when it comes to training your teams. You have one approach for each capability to train your teams in. So again, operational gains to be had. But if you think about deploying into a new location, perhaps for that new market, your team may need to make some upfront investment to ensure that that solution works there. Maybe that means they need to have customization and configuration. They need to build their own interfaces. And this all delays that time to market. If you have lots of different options for each of your capabilities, you may then have lots of vendors that you need to manage relationships of. And that will obviously have an impact on commercial and support arrangements that you have. Instead, you might opt for a capability-focused way to approach architecting your solution, where for each of your deployment locations, you're picking the best tool for the job at that particular location. And that might mean that you're adopting more managed services, perhaps. Now, whilst this might mean that you are training your teams in multiple approaches for the same capability, you can create niche pockets of expertise in your organization, small, lightweight, agile teams that can really drive efficiency for a given capability. By using the best available at a given deployment location, you speed up your time to market because you don't need to make that investment in integration and building interfaces. And this all has an impact in what your end solution looks like. Now, as I said, it's a balancing act. And in reality, you're probably going to end up with a container solution that is a mix of open source and cloud native that exists in multiple deployment locations, and some managed services that exist solely in single deployment locations. And as per the slide, it's a bit of a balancing act. You need to balance how this impacts the skills and learning plans for your team, how this impacts your commercial arrangements, how this impacts your operations and your speed to market. So we've defined a set of capabilities that we think our IT systems need to have. And once you've navigated this paradigm, hopefully you've come up with a set of principles that tells you, or at least gives you some governance. So for each capability, this is how we choose the tool. But we haven't actually gotten to the crux yet of how do I actually build a container solution? So Rob, how can the audience and customers actually build with AWS?
So like there's a trade-off between different capabilities. There's also a trade-off between different technologies and how we implement them. And there are many ways and options available to customers today to run containers on AWS. And there's different factors and different design considerations. AWS provides a variety of ways to deploy and run containers on AWS. And we can think of positioning these services into layers. So if we start at the bottom, think about capacity. This is where my container is going to run. Think Amazon EC2, AWS Fargate, our serverless offering. And with products like Amazon EKS Anywhere and Amazon ECS Anywhere, servers on premises or at the edge can also be considered capacity. From an orchestration perspective, to help you manage thousands of containers or hundreds, like Natasha mentioned,
drinks are being served in the partner
there are 3
area.
orchestrators that we provide to schedule and scale your environments: Amazon ECS, Amazon EKS, and Red Hat OpenShift on AWS. Red Hat OpenShift on AWS is a core managed service between AWS and Red Hat that allows you to run OpenShift on AWS in a fully managed way. The third layer is the vertical solutions layer, a set of vertical integration services that provide a higher level of abstraction and bundle services together that simplify the process of deploying and managing those containerized applications. Now let's pick 2 services to dive deeper into, Amazon ECS and Amazon EKS. Both services support a broad array of compute options and have deep integration with other AWS services, and provide the global scale and reliability you come to expect from AWS. The choice of orchestrator for container workloads is important. It's a key decision point and a key integration point. It will influence future decisions that you make. And one of the most common requests I hear from customers is, help me decide which container solution should I choose. We recommend that for most teams, they work backwards from their application requirements and their operational preference to select the most appropriate container service that's aligned to their solution. Amazon ECS is an opinionated container orchestration service. It makes it easy to deploy and manage containerized applications at scale. When you select to use Amazon ECS AWS Fargate, you get a serverless container orchestration, and you can leverage more of AWS operational excellence. What customers tell us they love about Amazon ECS is the simplicity it provides. It reduces the number of decision points that customers have to take to build, deploy, and migrate their containerized applications. Designed from simplicity from the start, using Amazon ECS decreases the number of decisions that need to be made around compute, networking, security, and other configurations, and some of the capabilities that Natasha mentioned around observability. For example, for service discovery, we have Amazon ECS Service Connect. It simplifies service discovery, connectivity, and traffic observability, while Amazon ECS Container Insights with CloudWatch makes it easy to collect, aggregate, and summarize metrics and logs. ECS is a great starting point if you want to move quickly. If you say, I'd like to use a managed Kubernetes service, we would recommend Amazon EKS as the best place for you to start. Amazon EKS provides the flexibility of Kubernetes with the security and resilience of being an AWS managed service. It's optimized for customers building highly available Kubernetes applications. Teams choose Kubernetes for its vibrant ecosystem, the community, the consistent open source APIs, and broad flexibility. They rely on Amazon EKS to handle the undifferentiated heavy lifting of managing Kubernetes at scale. So thinking about the Kubernetes control plane, etcd, the Kubernetes API server, for example. And we recognize that you might not be starting from scratch when you're building a container solution. You may have chosen Kubernetes at the core, but you have other services that are pre-existing in your estate that you'd like to integrate with. Amazon EKS gives you the flexibility to bring the services you want and build into that kind of flexible environment. So for example, with Amazon EKS, you might decide to use Nginx for ingress traffic management. Or if you want to use EKS with all our other AWS services, you can do this too. And we're continuing to prioritize Kubernetes-friendly integrations. Think of auto-scaling solutions like Carpenter and innovations like the AWS controllers for Kubernetes. Now, let's imagine you're all developers and you want to build something today. Imagine you recently joined as a full-stack developer and your first project was to build a booking microservice. I now want to show you two approaches of how we might do this. One with maximum flexibility, portability, and open source, and one that leverages as many AWS native services as possible to demonstrate that kind of flexible and portable solution that Natasha mentioned earlier. So as a developer, first you're going to create some code. You're going to package it in a container with all of its dependencies. To say you've got a Spring Boot application, you'll have a Java environment, and then you're going to test it locally. For example, you might decide to use a kind Kubernetes cluster to run Kubernetes locally, or you may use a tool like Finch as a local container development environment to build, test, and run your applications on your local workstation. But once tested, the developer is going to want to deploy this somewhere, so it can be accessed from other services, exposed maybe through a URL, so your QA team can interrogate that application and experiment with it. And we're also going to want to implement all the other capabilities Natasha mentioned, so things like observability, alerting, maybe integration with databases, etc. And of course, those other tools, vulnerability scanning and logging. So our developer decides on a solution that looks like this. The container build process is automated. When we create our container image, we need to store it somewhere in a registry. Today, we're going to use Amazon ECR, our Elastic Container Registry. In this example, we're using Amazon EKS. So when we deploy, we're going to use something like YAML or a Helm chart to deploy our container to our EKS environment. Next, we want to integrate this with those core capabilities our developer wants, that Tash mentioned earlier. that we need for a well-architected container solution to have. And these are observability, alerting, logging, and of course, vulnerability scanning. So what might this look like leveraging an AWS managed service approach? So I might use Amazon CloudWatch for my logging, my alerting, and my dashboards. X-ray for tracing between services. So finding out the communication between service A and service B. Is there latency? Is there an increased error rate, for example? Looking at services like Amazon Inspector for our container image scanning. So looking for CVEs, etc. But how do we design this for kind of maximum flexibility and open source? So there are some open source managed services approach that we can use to build maximum flexibility and portability into your architecture. These are things like Amazon Managed Prometheus, Amazon Managed Grafana, the AWS distro for OpenTelemetry for logging. And then you continue using other AWS managed services. But the real key takeaway here is that even though we've changed our tooling, we've changed our services, our container build pipeline hasn't changed. We're still building OCI-compliant container images. So our developer, Nikki in this case, is getting the benefits of the portability of the container and is still deploying their new Spring application the same way, but with all the capabilities they need. So we have the same capabilities even though we've changed our technology approach. So what might your decision journey look like when you approach containerization or maybe a migration journey? The first decision point, once you've understood, you defined your core tenants, your core architecture principles, is going to be picking a provisioner and an orchestrator. As we said earlier, this is going to influence future decisions down the line. So we're going to pick an orchestrator or a provisioner first. We then go, hey, where does my compute need to run? Does it need to run at the edge for low latency? Does it need to run on premises to process and filter data before sending it to the cloud for those generative AI models and training data that's being spoken about today? So think about the data plane. The third decision point you might have is go, what capabilities would I like to leverage? For example, for node auto-scaling, am I leveraging Carpenter? What does my observability tool stack look like? Am I going to use Amazon Managed Prometheus, Amazon Managed Grafana, or am I going to prefer Amazon CloudWatch? So think about the capabilities and the tools that you can leverage to enable those capabilities there. And the final thing is day two. How are we going to operate what we've built? What does patching look like? What does upgrades look like? What does it mean to operate this today? So this is what your decision journey may look like. You pick an orchestrator, you pick where you want your containers to run or your compute option, integrate those capabilities, and then how are we going to operate the solution? So think about how you might get started building containers on AWS today. There's a variety of resources, and I highly recommend checking out the AWS Containers Decision Guide, the Build Lens, which describes what good looks like for building container images. And if you'd like to get familiar with core concepts of Amazon EKS, I highly recommend checking out the EKS Digital Badge. And to stay up to date with our recent feature announcements, or if you'd like to raise a feature request yourself, please do check out the Containers Roadmap. And not to forget, we have AWS Skills Builder. There's over 600 free digital courses and hands-on labs that you can get familiar with. And the Amazon EKS Digital Badge is available there. So we'd like to thank you for your time. And
thank you very much. And enjoy the drinks and libations outside. And I hope you had a great day.
Thank you.
Thank you.